This module introduces how AI can be applied to improve business processes by increasing efficiency, accuracy, and decision-making quality. The focus is on enabling professionals to identify the right opportunities for AI and design solutions that solve real operational challenges. By integrating AI into workflows, organizations can reduce manual work, improve speed, and enhance customer experiences. The objective is to move from traditional processes to intelligent, data-driven systems that deliver measurable impact. Process improvement means reviewing current workflows to remove waste and reduce variation. With Lean, Six Sigma, and BPM, the focus was on people, processes, and performance. Now AI enhances this by adding automation, prediction, and optimization. DMAIC still applies in the AI era, giving deeper insights during measure and analyze. Metrics like cycle time, error rate, throughput, and cost per transaction help identify bottlenecks and guide improvements. Enhanced improvement focuses on combining RPA and AI to automate repetitive manual tasks with higher accuracy. It also predicts process failures or SLA breaches before they occur, allowing proactive action. The system recommends optimal resource allocation based on workload patterns. Real cases include Siemens using AI-driven maintenance scheduling to cut down time by 30%. Infosys BPM applied AI to auto-classify customer queries, reducing handling time by 45%. AI opportunities appear wherever processes have repetition, heavy rules, or high risk. Repetitive steps can be automated with bots, while rule-based decisions are improved using machine learning. Predictive models help reduce errors and prevent failures in risk-prone areas. Value stream mapping highlights delays and rework where AI can create impact. Using the 80/20 principle, teams prioritize high-value steps and classify them into predictive, prescriptive, or cognitive AI use cases. Real-world cases show how AI unlocks efficiency in everyday operations. Coca-Cola applied AI to optimize its bottling line schedules by analyzing demand patterns and machine maintenance needs, resulting in smoother production flow. HDFC Life implemented AI chatbots to automate policy servicing, reducing turnaround time by nearly 40%. These examples demonstrate how AI improves both speed and decision-making. They also highlight that the biggest gains come from applying AI where data, repetition, and business impact intersect. To effectively apply AI, we need clean and contextual process data. Start by identifying key data sources like ERP, CRM, Excel, IoT sensors, and logs. Next, collect event logs that capture timestamps, user IDs, and activity sequences. Ensure the data is cleaned and standardized for consistency. Finally, use process mining tools such as Celonis, UPath, or Power BI to analyze and optimize processes. In data collection and process mining, the goal is to discover the gap between actual and documented workflows. By analyzing event logs, we can quantify bottlenecks, delays, and handoffs that hinder efficiency. Creating digital twins of processes helps visualize and simulate workflows for optimization. For example, Vodafone used Celonis process mining to uncover inefficiencies in their order-to-cash process, saving €11 million in the first year. Similarly, Dell leveraged event logs to identify hidden bottlenecks in their service support, improving overall performance. These real-world outcomes demonstrate the significant impact of process mining in driving efficiency. Predictive analytics uses ML models to forecast outcomes and prevent issues. First, define the prediction goal like delays, defects, or churn. Then, train the models on historical data using regression or classification algorithms. For example, regression can predict time to complete, while classification detects defects. Finally, integrate predictions into dashboards for real-time optimization and proactive decision-making. FedEx uses predictive analytics to forecast package delays by analyzing weather, traffic, and staffing data. Maruti Suzuki, on the other hand, predicts machine failures using IoT sensors and machine learning, enabling preventive maintenance that reduced downtime by 25%. These real-world examples show how predictive analytics can optimize processes by proactively addressing potential issues, ultimately improving efficiency and reducing costs. AI improves demand forecasting, resource planning, and anomaly detection by going beyond traditional statistical models. For demand forecasting, deep learning and profit models can predict product demand more accurately. In resource planning, AI recommends the optimal allocation of workforce or machinery to maximize efficiency. For anomaly detection, machine learning algorithms can identify deviations in quality, cost, or compliance, helping prevent issues before they escalate. These AI-driven capabilities enhance decision-making, reduce costs, and ensure smooth operations across industries. For time series forecasting, ARIMA and LSTM models are commonly used to predict future trends based on historical data. For anomaly detection, techniques like isolation forests and autoencoders are effective in identifying outliers in data. For example, Amazon uses machine learning for inventory prediction and automated restocking, optimizing their supply chain. TCS applied AI-driven anomaly detection, reducing invoice errors by 70%. These real-world use cases show how advanced techniques like ARIMA, LSTM, and anomaly detection can drive operational efficiency and reduce errors. AI-driven decision support systems enhance human decision-making by offering insights and actionable recommendations. These systems are categorized into three types: descriptive, predictive, and prescriptive. Descriptive analytics focuses on answering what happened through reports and dashboards. Predictive analytics looks forward, answering what might happen by forecasting future trends. Prescriptive analytics takes it a step further, providing actionable advice on what should we do. To optimize decisions and outcomes, together these AI tools empower better, data-driven decision-making across industries. AI-driven decision support systems integrate machine learning models with business intelligence tools like Power BI combined with Azure ML to enhance decision-making. Natural language querying interfaces allow users to ask questions in plain language, making data more accessible. Generative AI copilots can summarize complex data and provide actionable decisions. For example, PepsiCo uses AI-assisted systems to optimize truck route planning, improving efficiency. Similarly, Unilever uses AI-driven dashboards to recommend production adjustments, helping reduce waste. These real-world applications show how AI enhances decision-making by providing intelligent, data-backed recommendations. Integrating AI with ERP and CRM systems embeds insights directly into operational processes. In ERP systems like SAP or Oracle, AI can predict inventory levels and automate approvals. In CRM systems like Salesforce or HubSpot, AI helps with lead scoring, churn prediction, and sentiment analysis. Integration is facilitated through APIs and connectors such as REST APIs or Azure ML endpoints. This seamless connection enhances decision-making and operational efficiency across the business. In this architecture, data is stored in a data lake where raw and structured data is collected for analysis. The AI engine processes this data, running machine learning models to generate predictions or insights. These insights are then delivered through ERP dashboards or used to trigger workflow actions. For example, SAP Leonardo AI embeds predictive insights directly into procurement workflows, improving decision-making. Salesforce Einstein provides AI-driven insights on customer conversion probabilities, helping sales teams prioritize leads. This architecture integrates AI seamlessly into business operations, enhancing efficiency and strategic decisions. AI-driven process optimization is delivering significant results across various industries. In manufacturing, predictive maintenance has reduced downtime by 25%. In the supply chain, AI-based route and load optimization cut logistics costs by 15%. For BPO services, chatbots have sped up ticket resolution by 40%. Healthcare has benefited from AI scheduling, increasing throughput by 30%, while retail has seen a 20% reduction in waste through better demand forecasting and inventory management. These case studies highlight AI's tangible impact on operational efficiency and cost savings. After implementing AI, it's crucial to measure its impact on business performance using key performance indicators (KPIs). The KPI framework should cover efficiency, quality, and financial metrics. Efficiency KPIs include cycle time, lead time, and throughput. Quality KPIs track defect rates, rework, and accuracy. Financial KPIs measure cost per unit, ROI, and productivity. AI-specific KPIs like model accuracy, automation rate, and adoption rate assess the effectiveness of AI solutions. To calculate ROI, use the formula ROI equals cost savings plus revenue gain, investment. This helps evaluate the financial success of AI initiatives. The balanced scorecard for AI helps measure AI's impact across multiple dimensions. For financial performance, you track ROI and cost savings. Customer metrics focus on response times and customer satisfaction. Process KPIs, such as automation percentage, measure how much of the process has been automated. Learning KPIs assess AI adoption rates and employee upskilling. A real-world example is IBM GBS, which created an AI KPI dashboard to measure process automation ROI across global delivery centers, helping them track performance and optimize AI implementation. AI-driven continuous improvement combines lean principles with AI to create a feedback loop for ongoing optimization. Lean defines the process, while AI provides predictions, detects anomalies, and offers recommendations. Data is captured from sensors, systems, and people, then analyzed by AI for insights. Human review ensures decisions are made, which are then automated through workflows. The feedback loop retrains AI with new data, fostering continuous improvement.